Okay, here we go. This is the name of my talk, Best Practices Running an iOS Open Source Project on GitHub. Now, the ones of you who haven't seen my first talk, that's a brief introduction. I'm Oliver Drobnik, and I'm a full-time iOS developer and blogger since January 2010. Since then, I've created and maintained a couple projects on GitHub. I've put them here sorted by the number of stars. These are just the top 10 ones. I have a couple that have little less stars than that. But this kind of gives me a little bit of an idea how to approach running an open source project. And I have some opinions how to do that. And that's what I want to share with you. Before I go into that though, I want to briefly mention over the last year I've been working on a book, Barcodes with iOS. That's coming out soon with Manning, and because they like you developers so much, you get 44% off with promo code Mobiconf for the win. On all books on Manning.com, and also if you tweet something about this talk and you mention Barcodes iOS hashtag, you have a chance to win a free copy. Yeah, so do that. And here we go. Let's start the talk with some open source wisdom. Whatever is worth doing at all is worth doing well. You probably don't know who said that because this guy is long dead. It was Philip Stanhope, the 4th Earl of Chesterfield, in a letter to his son. But it doesn't mean that it's outdated wisdom, because really, if something is worth doing, you should do your best to do it well. So the first question to ask ourselves about open source, is it actually worth doing? Well, here's some thoughts that I have to that. The first thing about doing an open source project is it teaches you something as a developer. It teaches you to feel that you overflow with good ideas for code, and you are able to well, you don't fear that maybe one day you will not be able to program anymore. That's what I basically want to say with that. Others get the opportunity to add functionality to your open source project that might not fit your current project where you are using such a component. Others can point out assumptions of yours that are incorrect, and from this you can learn a great deal. Others can also fix bugs, yeah? And sometimes bugs only appear within the context of another person's app. So you have a very nice open source framework, and you just don't have the amount of different kinds of apps that put it through these situations where sometimes a bug might arise that you don't know about, and somebody else having this in their app by accident stumbles on it, they can fix it and thus improve the project for everybody. And another thing, there's often the notion, yeah, with open source you cannot make money. Well, I've been making a little bit of money with my open source projects, because I'll show you in a second one way to do that by means of using a BSD license, or by people having to pay or paying to avoid having to attribute. So that's what we're going to be covering soon. And the other thing that's quite an interesting factor is the work that you put open source is seen by people like recruiters, people like decision makers in companies, and often it's like a good business card for you if you have a nicely documented, well-run open source project that somebody from, say, Facebook or Apple or Google might contact you and ask you to work for them. So having established that it's probably worth doing, it's probably also worth doing well. And these are the things that I'm going to cover in my speech that we're going to go through one by one. But a word of warning, all of these are my personal opinion. Yeah? I'm not one of those really big guys with hundreds of thousands of stars. I have one project that has several thousand. I have one that has a couple of hundred. So that's mostly what I came to know as my own best practices. But I'm thinking maybe some of the thoughts that I put in this might inspire you to maybe do a slight modification on the way how you do it, or it might inspire you to even open source something in the first place. So the first thing to talk about is what I find really incredibly important with an open source project is that it has a well-organized folder structure, that things like references in Xcode match up with how the folders look on disk. That's something we have somebody from JetBrains here in AppCode. My brother-in-law who works for me always tells me, yeah, in AppCode, you see, that's always perfectly matching up. And with Xcode, you can have a reference that looks like a folder, but in reality is not on disk. And what I'm saying here is you should try to have these match up because otherwise it's confusing. At the project root, you probably want to have two things. One, you want a README that sort of explains what the project is about, yeah, like in a couple of sentences why you actually chose to make this an open source project. And the second thing you want to have in the root of your project is a license file. Because if somebody finds it on GitHub, probably the second or third question he asks himself is, well, am I allowed to use that? And if there's no license file, he doesn't know under which conditions he can use it. And I generally like to use the BSD 2-clause license. Let me briefly explain why. The first thing is there's a certain copyright that's attached. I claim that I own that the copyright for the code that I put into the open source repository, I own the copyright for that. So that's kind of the most important thing. The second thing is the first paragraph is about redistributing the project in source code form. It's usually not happening that somebody takes like my whole open source project and distributes that as source code with somebody else. Let me say that again. It happens rarely that somebody distributes an entire project in source code format and then he would want to include my source code as well. But in case they do, there is this first paragraph that says that this license has to accompany the source. The second one is way more important. Oh no, I lost the connection again. That is for binary distribution. So if you use open source that's covered by such a license in an app, the app needs to somehow display this license text. One way to do that is like in the settings to have third-party acknowledgements or so. Or the other option is, and that is what I mentioned before, I'm offering people to pay me a couple of euros in order for me to waive this. So I call it a non-attribution license. You can buy it for all my open source components on my website. And that basically means you can use my source code, but you don't have to say it's copyright Oliver Drobnik. And the last thing in here is also quite important for legal reasons. That is, you don't give any warranty. Yeah? So if somebody is using this, he's using it at their own risk. And you cannot be held responsible for if something goes wrong because of them using your source code. So that's why you have the license there. So speaking about folder structure, I have a certain way how I'm laying out my projects. I have at the root, again, a folder that I name core. And core is sort of the core code that makes up the functionality of the framework or the component that I'm offering here. And this has two subfolders, one with source, that's obviously the source code for it. Often components also have resources. These I like to have in a separate folder called resources. Yeah? The same kind of structure also exists under the term demo. This is usually a demo app that uses the open source component and shows how it's basically used. And often this demo app is also what I use to develop the component, because in the context of an app, I can quickly add some UI to implement some functionality, and then I see that the whole thing is actually working. Yeah, so that's why it's always good to have a demo, and also for somebody who doesn't kind of like to read the fucking manual, yeah, it's good to have a demo to look at how this is actually being used. Then, if I happen to have unit tests, I like to have them in a third folder that I just named test. And again, there's source and resources. So the core component can have source code and resources. The demo app can have, or most likely has, source code, like an app delegate, and resources, like the app icon. And also, the unit tests can have, or must have, source code. And sometimes they have special resources that are only used in the context of unit tests. But you see, since I'm always following this same scheme of having source and resources separately, it's kind of, yeah, you know where to find the things that you're looking for. I do have two further folders at the root. One is documentation. There I put things like the changelog, for example, and other dedicated things that I need for auto-generating the documentation, which I will be talking in a few minutes about. And finally, there's a folder named externals. If my component has some external references as GIT submodules, yeah, then I put this there. Yeah. So with this setup, yeah, you basically have at most 5 folders in the project root, and it's quite clear what you would find where. Now let's talk about a little bit what's going on in these individual subtrees. Yeah, the main source of my component is in the core, and it's in core source. And what happens with that is, from this I build a static library, and from the resources, because you might be aware you cannot package resources like images into a static library. So for this, I'm building a resource bundle. Yeah? So I have 2 targets. One, if there are resources. It doesn't mean I have to have resources all the time. But I have some project where I do have resources, and those are then bundled up in a resource bundle. Yeah? So that is about core. Yeah? Looking at demo. Yeah? Obviously, the source and the resources of the demo application end up as an app. Yeah? But somehow the resources and the code from core also need to be added to the app. Something that I don't like, some other open source vendor do that, is that they just also compile the components, the core code with the app, but that's not a clean separation. So what I like to do instead is, as I said before, the source for the core of the component ends up in a static library, and I just link that with my app. And so everything is basically 2 build steps. Yeah, first the static library for the core is built, and then the whole thing is linked with the app. And if I have resources, first I have a resource bundle that's being built, and this resource bundle is then added to the app bundle. Yeah, so my component code can still rely on there being a bundle available within the app bundle to get string resources, zip files, images from. So this is the whole folder structure that I'm following with all my projects, and now you know your way around that. And I think this is kind of gives you an advantage, because with every new component or project of mine, you will never be surprised where to find things. I even follow the same structure if I'm doing an app project. Even though there, I don't call it core, but it's just the name of the app, yeah, that I have. But I still have always this separation between source and resources. And one thing I forgot to mention so far, if you have, we'll be touching on Cocoapods later, and you might have subcomponents of this project. And where would you find these? Well, each of these subcomponents would be a subfolder underneath core source. Yeah? So, for example, in DT Foundation, I have some code that's only relevant for iOS apps. Yeah? So I have core source / iOS. That's where the source code is for this sub-spec, as they call it in Cocoapods jargon. Now, about unit tests, yeah, the same happens here, but it's not an app that gets built, it's a XC test bundle. But the same process applies. The static library from core source gets built and added there. And as well, if there are resources, a resource bundle gets built and is also added there. Yeah? So that's how you can see I always have just one place where something is built. Yeah? One particular .m file from core is only built in one target and not like in 5 different ones. So this gives it a good, you have an easier way to understand what's going on in this project. So that's the first point of my doing well. Yeah? The second point I'm going to talk about is a good open source project should allow multiple integration options. Yeah? And I'm going to cover 2. The first one to cover is obviously the classical one. You can always add a GIT submodule. Say you have an app and you want to use one of these components. How do you integrate it? You GIT submodule add the submodule via the path from GitHub. So it gets added. As I said before, I have it always in the folder called externals. The second thing you need to do is you need to add a reference to the components Xcode project within Xcode, because then within the context of your app, you can also see the Xcode project with all its targets for the component. Yeah? Then in order for Xcode to know how to find the headers, you need to add it as a search path. The tricky thing is, well, that's not yet the tricky thing. You need to link the static library target from the sub-project / submodule into your app. But what's tricky about this is you need -obvious-c as a linker flag, because otherwise the linker will optimize away all the symbols that it thinks you're not using. And for example, one would be if you have a category, like you have a category on any string, yeah, that's something that gets lost without the -obvious-c linker flag. And finally, if you do have some a resource bundle target in your component, you want to copy that as the copy bundle resources phase into your app. So you see, it's like a little bit involved, yeah? But this is kind of the classic approach. And I'm against saying, okay, if I don't want anybody to use my code like that. So I'd rather say, okay, if somebody insists, this is an option he or she has. Yeah? Obviously, the more modern version, and we had several talks on these 2 days where that was mentioned, and I also am a fan of Cocoapods. Yeah? Integration via Cocoapods of my frameworks is quite easy. It's actually just one line that you add to your pod file. Yeah? In this case, I'm adding the sub-spec DT side panel of DT Foundation. And the thing that's great about that is this tilde greater operator means it's going to use version 160, 161, 162. Yeah? So the first digits have to be identical, but the last one, anything equal or greater. Yeah? That's a little bit, I didn't understand that in the beginning. Yeah? So this means all the versions that fix bugs, yeah, I would only increment the patch version, the one on the very right, and the pod file would be able to use all of them. Yeah? Now, one of the problems you might encounter when working with a team is that you don't want, or if you work with a continuous integration system, you always want to use specific versions of something. And there's an advantage in using a GIT submodule, because there the submodule always points to a specific char of the component. So even if you check this out on a continuous integration server, you end up with exactly the same version. That's has been a slight drawback in the past of Cocoapods, but there is a sort of solution. The first time you run pod install, it creates a podfile.log, which basically specifies the versions of the submodules, yeah, the pods you use. And the next time somebody does pod install, he will get the same versions. So imagine this, you as a developer, you set up your app, yeah, you specify, I want to use GIT side panel, then you do pod install, so it installs the pod, your app works, and the pod file as well as the podfile.log are the ones that you put in your repository. And now the continuous integration server, or maybe a colleague of yours, when he checks out your app project, of course he doesn't have the pod source file yet, so he does pod install himself, but because there's already a pod file log, he will get exactly the same versions of the pods that you had when running pod install. There is a slight gotcha there. I was informed yesterday. If you have a pod that references another pod and doesn't specifically lock down the version there, you might be out of luck. But Cocoapods people, I was told, are working on that so that in the future, this is the intended behavior. And well, what would you do if you want to update the pod? Well, you run pod update. Yeah? Then it would go find what's a newer version that fits this 160 pattern and would create a new pod file log, which you then again put in your repository, and everybody else again does pod install, yeah, so to get the version that he wants. Yeah. So let's briefly have a look at creating a pod spec. I won't bore you with all the details, but because of the well-organized folder structure, it's relatively simple to create such a spec file. Basically, you just specify the folder where the files are that are supposed to go in the spec. So for the core spec, yeah, it's all the headers and all the implementation files in core source. And for subspecs, well, it's core source subspec name and then the headers and the implementation. And just as easy for resource bundles, there's a slightly different syntax, but you basically tell Cocoapods the resource bundle dt_loop.bundle takes the files that are in core resources, and in this case, all the PNGs. And the advantage of doing that versus having like a static bundle, I've seen that sometimes, is the resources get processed by Xcode. And for example, a PNG file needs to be processed. When Xcode puts a PNG file into an app bundle, it's not just a copy, but it's actually optimized for iPhone hardware. You might know that. Yeah? The same with string files, the same with interface builder files. There's some work that goes on these files, and it's less efficient if you have like just a folder that has PNGs and strings. So that's the way how you should do it. Okay, this works again. So that's enough about how to integrate it. The next thing that's quite important to me that I would like to touch on is documentation. Yeah? You might ask yourself, why do I need documentation? I'm a developer. I hate documentation. Yeah? So one thing that I found is documentation in header comments for files is a great way to basically talk to yourself about what did you want to achieve with this class. Why have you created this class? And so that's a thing you might put at the top. You can clarify what reasons there are for certain public methods to be existing. Like in a header, you only see the public methods. So why did you put them in there? Another advantage is you get automatic support in Xcode. At least if you option click on a method name, it tells you the parameters and the description of the method. I'll show you on the next slide. Another thing is if you do auto-completion, it also shows you the description of the parameters that you put in the header. What you can do is you can generate documentation that gets installed in Xcode. Yeah? It can create like a XR, it's called, and that gets installed in Xcode. So you can search for functions that your library provides. Yeah? Best of all, you can also create HTML documentation which you might want to put on your web server. Yeah? All my components, I have a server, docs.coconetics.com, and there the HTML documentation is available for all my components. Yeah? And the great thing also is you don't like to document. So if it makes you think, do I really need this public method? Yeah? And you think, actually, it's a private method, so it doesn't need to be public. Great, then I don't need to put it in the header. Then I don't need to document it. Yeah? So it allows you to have a dialogue with yourself. Do I really need this class? Do I really need this method? And it makes the headers very manageable, very easy to understand. And here's an example. This is a class of my DT Core Text open source method. And you see at the top, there's the class description. Yeah? In the middle with add name is a section. And here at the bottom is a method description. And what appledoc does is when generating the HTML documentation, it groups the methods by section. Yeah? Unfortunately, this section is not supported by Xcode, so let's leave that out for now. But the important thing is class description and method description. And what happens if you alt-click on the font descriptor, you get a nice pop-out like that. Yeah? And there's nothing you need to do. You just need to add the comments, and Xcode supports it everywhere, yeah? In all your code. The same with method descriptions. And you can see all the values that are at the top in the comments appear also in the pop-up. So isn't that a great thing? If somebody else is seeing this code, there's a great description how to use it. And the next thing I want to point out is appledoc by Tomaz Kragelj. Yeah? He basically wrote a parser that goes through the files that you specify it and finds comments that are in Doxygen format. And Doxygen is sort of the commercial version, and appledoc is free and open source. They are mostly compatible. Yeah? One thing they are not compatible, for example, is the thing with this method section. Yeah? But you don't need to use the sections as long as you have the same, there's a text on top of each method and the parameters and the return. These are things that both of them share, so no problem using them. What it does is it scans specified files for these documentation comments. You can put all the settings you want for your help file into appledoc settings.plist, and that makes it much easier then to generate the documentation, because all you need to do is run appledoc -o path where it should go, and then beginning from the current path. Yeah? That's what I'm also then using a few slides in the future to check the documentation. And because appledoc and Doxygen are sort of on equal footing, there's a great advantage you have if you if you enable the documentation comments warning in Xcode. Because what happens then is the functionality I showed before, that you get pop-ups for methods and classes, that's actually a feature of LLVM. LLVM, I think since version 5, is inline compiling or kind of on-the-fly compiling your code, and also picks out these comment tokens. And from this, Xcode then creates these pop-ups. And documentation comments, the warning, will give you information like you have a parameter that's not documented, or you have one thing that I encountered, for example, I had an add return comment for a method that didn't have a return value. It was void. Get a warning, yeah? So you can get rid of that, and basically this helps you clean up your comments. Next topic, Git branching and pull requests. I like to use the so-called successful Git branching model. It's something that was first described by a guy on a blog post. If you enter successful Git branching in Google, you'll find it. And I won't bother you with all the details, but just the most important things about this is all my development happens in a develop branch. Yeah? If I have something that I will probably have multiple commits for, I do these in a feature branch that I branch off develop, yeah, do my work, and when I'm done, I merge it back into develop. If I do a release, yeah, I branch off develop into a release branch, do a couple of things like add a changelog, change some version, and then I merge that into master. And one tip maybe, in order to avoid people sending you pull requests that are branched off master on GitHub and probably most other Git repository solutions, you can specify a default branch. And the default branch is the one that you get if you do git clone. Yeah? So if you do git clone on any of my projects, you will be automatically on the develop branch. So how does this look like on GitHub? Yeah? Here, one component of mine, DT Bonjour, you see I have the master branch has progressed at the top, and development went on the green line, and there's multiple things that happened, and they have always been merged back. So the last bullet you see on the master branch has been release 110. Yeah? So after release 110, some work progressed. Somebody contributed a fix. Yeah? This fix was merged. Yeah? And so that's how it might go on for a couple of weeks. Yeah? The stable version remained at 110, and the development version progressed. Yeah? So one question here is, how do you make sure that the things you merge into your project don't destabilize it, don't introduce side effects? Yeah? So that's one thing that I want to touch on, that is pull request quality, sort of. Yeah? And one tool that I like for that is Travis CI. Travis CI is a free continuous integration service, free for open source projects. With a little bit of extra money, you can also use this for your private projects. As I said, continuous integration, that means every time you push something to the repository, a build is automatically done. And the cool thing about that is you get an actual virtual machine that builds your code, and once it's done with that, it's basically gone again. And you don't ever have to worry about installing continuous integration servers or so. As I said, builds every push to any branch. And not just that, it also builds automatically pull requests. And then in the pull request message at GitHub, you get a message added like this. Say, for example, something failed in the build. Yeah? This is something you might not want to immediately merge into your project because something is wrong. Yeah? Either the build failed or some unit test failed. It says so, did not complete, merge with caution. And what you usually want to end up happening is that after some fixes done by the person sending you the pull request, this should be green, all is well, the build passed, and you can just merge the thing by pushing the green button. The other thing about pull request quality is if you're looking at the code coverage of your source code, yeah, there's a free service called Coveralls.io, Again, free for open source with a little bit of extra money. You can also use this for private repositories. And what it does is it tracks changes in coverage. Now, let me briefly explain what is coverage. Coverage is only useful if you have unit tests, and it's a measure how many of your source code lines are visited by your unit tests. Yeah? So if you see there's certain methods that are never visited, yeah, that means you probably would need a unit test for them. Yeah? Because if functionality of these lines changes, yeah, you wouldn't know about it. So that's why you need a unit test for them, because then the unit test would, with a certain input, expect a certain output. And if the output changes, then you know, oh, something is wrong. And what Coverall offers is that you see changes over time. You get a nice web UI where you see these are the files, how much covered are they, yeah? What are the ones with 100%. That's a good thing to have, but as I said, unfortunately you need to have unit tests for that. So if you already do unit tests for everything, then great, use it. If not, maybe you should start having unit tests. Unlike Travis, it's not automatically working with pull requests and so on, but instead the coverage information has to be pushed to their API. It's a HTTP-based API directly from a build in Travis CI. And just like Travis, it's also able to comment pull requests. And what it does is, for example, here, the coverage decreased slightly because I was developing the develop branch of JC13 into Coconetics develop for this project. So if I were extra strict, I would tell Mr. JC13, no, I'm not going to pull that. Please add a unit test for the new code that you wrote, because my coverage is decreasing, if you want to be so anal. Yeah? So let's have a look at how does this Travis build file look like. This is for my DT Foundation project. It is an Objective-C project. That's what you specify with the language. Since I'm pushing to coveralls, I'm getting via easy install a C tool that knows how to push. Yeah? I'm also building all the demo app schemes just to make sure that they still build. Yeah? The thing to say about this is you can only build schemes that are shared. Yeah? If you create a scheme in Xcode, that's only available on your machine. So you need to check the shared check mark in the manage schemes. Then you can add it to your repository, and then it's also available for other users or for a continuous integration environment like that. The thing that's most important is the last line here, because this builds the static library, scheme, and or target, which is essentially the same, performs the unit tests, which you see it does build and test, and then it also collects code coverage data by specifying the build configuration coverage. And the build configuration coverage is basically just a copy of debug, but with two settings enabled, the instrument program flow and the create coverage information in Xcode, so that whenever this code is run in iPhone Simulator, the coverage information is collected. Coverage information is basically which line in which file was touched how often. Yeah? And this all gets collected in the end, but before that happens, I still have one more thing that I think is a great idea. I call it the docs unit test. By just running appledoc like that, it's the full process that generates documentation. But if appledoc, discovers, for example, a missing parameter in a method, you get a warning, and that causes this line to return a status code where Travis then assumes the build to be failed. So what happens is in the pull request, I get a failure notice, and then I can tell the person sending me the pull request, can you please also add documentation for parameter X? Guy does that, another build happens, and now it's green, and now I can merge, and I don't have to worry about my documentation being incomplete because somebody sent me something missing, some documentation. And the last thing here is pushing the coverage files. It's basically going, in this case, coveralls.rb is a Ruby script I wrote that goes through the entire tree, picks the coverage information, and then sends it via the CPP coveralls to coveralls. So, next thing to talk about is the final piece of the puzzle, issues, milestones, and making beautiful releases. So about tracking issues, I believe that you should create an issue on GitHub for any kind of problem that you face. Yeah? It's better to have it kind of online and visible so that people can discuss, people can say, well, I'm seeing the same in this and this context, so you have sort of documentation that you collect for the individual issues. There are tags that you can put to things, like if something is just a question, it gets the question tag. If it's a bug, yeah, it gets a bug tag. If it's an enhancement or feature, it gets this tag. And what you can also do is if there's multiple developers involved, you can assign them to these developers so that somebody feels responsible for the issue. Pull requests on GitHub are issues too. Yeah? Gets a hash number and is treated the same as an issue. What you can do is you can reference the issue number or the pull request number in a commit. Yeah? Like you can write, this and this is what I did, fixes hash 3. And what happens in this case is as soon as this commit ends up on GitHub, it closes the issue for you. So you don't have to click on the close button, but you get the message in GitHub closed by this commit. And the other thing is it's a nice way to group your commits to certain issues. Because then if you look at the issue, you see, these are the commits that were that happened in order to address this issue. And the other thing that I like to do is group issues by release. Yeah? If you create a milestone, you can specify when do you plan to release this. You can assign issues to certain milestones. And as you close the issues one by one, you see, in this case, there are 3 issues assigned to 1.6.14. And of these, 1 is done. And you have like a progress bar where you see, OK, that's how much work remains before we can release this milestone. So how does this look like? This is where we left off before. Yeah? I've merged back this change into develop. And now I want to release the whole thing. Yeah? So first thing I do is I create a release branch. In this case, release 1.1.1. I updated the version in the pod spec. I updated the changelog, saying, OK, these are the numerous fixes that ended up in this release. And then in the end, I merged the release branch into master with -- no ff. And that is the same what GitHub does when you push the green button. This doesn't merge the commits into your master branch, but rather creates a merge node like that. And so you see you have a very nice and clean master. And ideally, the only times when develop ends up in master is when you do a release. So that's you have at a glance the information since the last release. These are the things that happened, and now there's a new release. And I think that's a good thing to aspire for. And the other thing that I do, and at this case, is I tag this merge with the version number. Yeah, 1.1.1 in this case. So what are the chores to do for a release? Yeah, of course, the release branching stuff that I just showed. You want to update the version number in your pod spec. You want to update the changelog. And then GitHub has a page releases where you can also copy your changelog, which is obviously in Markdown. Yeah? you can copy it there as well, and then GitHub shows all the releases with sort of the changelog in a really nice way. And if people want, they can even get a zip file of a specific version of your project because of that. And what I also like to do is make an announcement blog post on my blog. And one thing that I sometimes forget, but you should always do is merge these changes that you just got in master and not yet in develop, merge them back into the develop, so that you don't get these don't cause unnecessary merges down the road. Yeah. So, and here I don't use the -- no FF because that doesn't really matter. I just want to, if you continue work, I want basically just go on like that. Yeah? So in summary, I'm enforcing a organized folder structure just so that I can find things if I look for them. I provide multiple integration options, GIT Submodule versus Cocoapods. I document the public headers. I use the successful Git branching methodology. I let continuous integration and code coverage track my quality of my own work as well as the work of people contributing to the projects. And I'm tracking issues so that I can make beautiful releases that I'm proud of. And with that, thank you for watching. You can reach me on Twitter via @Coconetics, and I'm also a developer evangelist for this other startup, Product Layer, and all of these addresses with a .com are the homepages, and with a Oliver@ are my email address. So thank you now.